Hello and welcome to another video. Today in this video I'm going to teach you everything about TensorFlow Tensors in 5 easy steps. Entire source is published online and with explanation. Please check the link below in description. We will cover all the topics related to tensors in TensorFlow in these 5 simple steps. Step I. Definition of tensors. What is a tensor? Step 2. Creation of tensors functions to create tensor objects. Step 3. Qualifications of tensors. Characteristics and features of tensor objects. Step 4. Operations with tensors. Indexing, basic tensor operations, shape manipulation, and broadcasting. Step V. Special types of tensors. Special tensor types other than regular tensors. What is tensor? Tensors are TensorFlow's multidimensional arrays with uniform type. They are very similar to NumPy arrays, and they are immutable, which means that they cannot be altered once created. You can only create a new copy with the edits. Let's see how tensors work with code example. But first, to work with TensorFlow objects, we need to import the TensorFlow library. We often use NumPy with TensorFlow, so let's also import NumPy with the following lines. Creation of tensors, creating tensor objects. There are several ways to create a tensor object. Let's start with a few examples. You can create tensor objects with several TensorFlow functions, as shown in the below examples. As you can see, we created tensor objects with the shape 1, 5, with 3 different functions and a 4th tensor object with the shape 5, using tf.range function. Note that tf.1s and tf.0s accepts the shape as the required argument since their element values are predetermined. Qualifications of tensors, characteristics and features of tensor objects. TensorFlow tensors are created as tensor objects, and they have several characteristic features. First of all, they have a rank based on the number of dimensions they have. Secondly, they have a shape, a list that consists of the lengths of all their dimensions. All tensors have a size, which is the total number of elements within a tensor. Finally, their elements are all recorded in a uniform type, data type. Let's take a closer look at each of these features. Rank system and dimension. Tensors are categorized based on the number of dimensions they have. Rank 2 tensor, a tensor containing 2 axes, 2 dimensions, and rank n tensor, a tensor containing n axes, n dimensions. For example, we can create a rank 3 tensor by passing a 3-level nested list object to the tf.constant function. For this example, we can split the numbers into a 3-level nested list with 3 elements at each level. We can view the number of dimensions that our rank _3 tensor object currently has with the .ndim attribute. The shape feature is another attribute that every tensor has. It shows the size of each dimension in the form of a list. We can view the shape of the rank _3 tensor object we created with the .shape attribute, as shown below. As you can see, our tensor has 2 elements at the first level, 2 elements in the second level, and 3 elements in the third level. Size is another feature that tensors have, and it means the total number of elements a tensor has. We cannot measure the size with an attribute of the tensor object. Instead, we need to use tf.size function. Finally, we will convert the output to NumPy with the instance function.numpy to get a more readable result. Tensors often contain numerical data types such as floats and ints, but may contain many other data types such as complex numbers and strings. Each tensor object, however, must store all its elements in a single uniform data type. Therefore, we can also view the type of data selected for a particular tensor object with the .type attribute, as shown below. Operations with tensors. Indexing. An index is a numerical representation of an item's position in a sequence. This sequence can refer to many things: a list, a string of characters, or any arbitrary sequence of values. TensorFlow also follows standard Python indexing rules, which is similar to list indexing or NumPy array indexing. A few rules about indexing. Indices start at 0, 0. Negative index, n, value means backward counting from the end. Colons, colon, are used for slicing, start, stop, step. Let's create a rank underscore 1 underscore tensor with the following lines. Now, let's create our rank underscore 2 underscore tensor object with the following code. Basic operations with tensors. You can easily do basic math operations on tensors such as addition, element-wise multiplication, matrix multiplication, finding the maximum or minimum, finding the index of the max element, computing softmax value. Let's see these operations in action. We will create two tensor objects and apply these operations. We can start with addition. Let's continue with the element-wise multiplication.